Alright, let me unlock my computer first. There we go. My computer just recognized my face, and now I have access. But how did it actually do that? How can a machine see and understand what it's looking at? If you have ever wondered how AI interprets images like this, you are in the right place. Hi, I'm Sarah Alali, a senior technical trainer at Microsoft, specializing in AI, Copilot, and building intelligent and secure applications on Microsoft Azure. I have a PhD in computer science and 12 years teaching training experience. This course covers 12 sessions where we will dive into core AI concepts in Azure and learn how to turn ideas into real applications using modern tools like Microsoft Foundry. In session number 9, we will cover an introduction to computer vision concepts, and I will walk you through the key concepts of computer vision. Because recognizing a face is just one example, AI can actually understand images in many different ways. Let's explore the main type of computer vision tasks. Computer vision is about helping machines see and understand images, videos, or live camera streams. But understanding an image can mean very different things. That's why it's important to understand the main computer vision tasks and how they differ. Let's walk through the most common one. The simplest computer vision task is image classification. In image classification, the model looks at an image and assigns one label to it. There is no where involved, just what the image is about. For example, like in the slide, you may ask, is this an apple or an orange? Or in a business context, is this a damaged product or a normal one? Is this a receipt or a legal document? Image classification is used when one label for the whole image is enough. Now we have object detection. Object detection takes things a step further. Instead of just identifying what's the image, it also answers where the objects are within the image. For example, in the image of the slide, we ask, where are the bananas in the image? The model detects each object and draws the box around it. In business, this is commonly used in warehouse automation to locate packages, retail stores to detect product on shelves, and traffic systems to identify vehicles and pedestrians. Object detection tells you what is present and where it appears within your image. Next, we have semantic segmentation. Semantic segmentation is even more detailed. Here, the model labels every pixel in the image. For example, which pixels belongs to the apple? Instead of a box, you get a precise outline of the object. This is useful when accuracy matters, such as medical imaging to isolate organs, or maybe manufacturing to detect defects, or satellite imagery to distinguish roads, buildings, and vegetation. Segmentation provides a pixel-level understanding of the image. The most advanced task is contextual image analysis. This goes beyond recognizing objects. It focuses on understanding what is happening in the scene. For example, a person eating an apple, like the image in the slide. Or maybe a delivery driver is placing a package next to the door. In business, this is used to generate image captions, or maybe tag content automatically. Understand activities in image for media, or maybe security or analytics. This task combines vision with language for deeper understanding. Each task answers a different question. Classification answers what is this? Detection answers what and where. Segmentation answers exactly which pixel. Contextual analysis answers what is happening. That's why different tasks require different models. Choosing the right computer vision task depends on the problem you are trying to solve. Now that we have seen the main computer vision tasks, the next question is, how do machines actually learn to understand images? This is where computer vision models come in. There are two main approaches you should know: convolutional neural network, or CNNs, and vision transformers, often called VTs. Let's start with CNNs. CNNs have been the foundation of computer vision for many years. The idea is actually quite intuitive. A CNN looks at an image and applies filters to detect patterns like edges, shapes, and texture. You can think of these filters like lenses that highlight specific features. For example, in a retail scenario, a CNN may detect edges of product, then shapes like a bottle, and eventually recognize it as a water bottle. As the image passes through the model, this filter creates something called feature maps. Feature maps are basically summaries of what the model sees. They capture patterns like there is a round shape here or there is a straight edge there. Then these features are flattened and passed into a fully connected neural network, which predict the final result. For example, the product category. The output is usually a list of probabilities. For example, this image is 80% likely to be water bottle, 15% a soda, and 5% something else. A simple way to think about CNNs is this: they learn by looking at a lot of labeled images. For example, show them thousands of product images with labels, and they learn which visual features match each product. All right, now let's move to a newer approach: vision transformers. Instead of scanning the image with filters, a vision transformer takes a different approach. It splits the image into small patches, like tiles, and each patch is then converted into a vector, which is just a set of numbers that represent that part of the image. Once the image is converted into patches, the model uses something called attention. Attention helps the model understand how different parts of the image relate to each other. For example, instead of just recognizing a face and a hat separately, the model learns that hats are often on top of the head, and this is what allows it to understand the image at a global level, not just locally. Imagine a security camera image. A CNN might detect a person, a bag, a doorway. A vision transformer goes further and understands it's a person entering a building with a bag. That's a more complete understanding of the scene. Here's the key difference. CNNs focus on local patterns like edges, shapes, where vision transformers focus on global context, meaning relationship across the whole image. Both are powerful, but they approach the problem differently. So far we have talked about understanding images. Now let's flip the problem. What if AI doesn't just understand images, but actually create them? That's where image and video generation comes in. Imagine a marketing team preparing a campaign. Instead of searching for stock images, they simply type a modern office with people collaborating around a digital whiteboard, and within seconds, AI generates a custom image that matches the description. This is powered by diffusion models. Now, what is diffusion models? A diffusion model works in a very interesting way. Instead of directly creating an image, it learns by adding noise to the image during training, and then learning how that noise changed the image. You can think of it like taking a clear photo and gradually turning it into TV static. Over time, the model learns exactly how the image gets distorted. Then it reverses the process. When generating a new image, the process is reversed. The model starts with random pixel, like TV static, and then removes noise step by step, until meaningful image appears. Each step makes the image clearer and closer to the description. A simple way to understand this is it's like sculpting an image out of static. You start with a block of noise and gradually remove what doesn't belong until the final shape appears. Now here's the key idea. The model doesn't remove noise randomly. It is guided by a prompt. The prompt tells the model which visual features to keep and which noise to remove. For example, if you say a dog carrying a stick in a park, the model will favor shapes like a dog, add texture like a fur, and build background like grass and trees. Each iteration moves closer to that description. The same idea can be applied to videos generation. Instead of generating one images, the model generates a sequence of frames. It also ensures movements look natural, objects behave realistically, and scenes evolve consistently over time. This is already used in many business scenarios. Marketing teams generate campaign visual instantly. E-commerce platform creates product images from description. Media teams prototype videos content without filming. Designers explore idea faster by generating variation from prompts. And also, that's how we created for you the AI virtual trainer Anton videos on the course learning path. Now let's do a quick exercise where we explore computer vision in a browser-based chat playground. You can also practice this exercise by accessing the lab steps in the link that you can see on the screen or by visiting the AI-901 learning path through the Microsoft Learn platform. Let's go. In this exercise, we are going to explore computer vision using the chat playground and interact with generative AI solution that can analyze actually and interpret images. The goal of this exercise is to explore a common pattern from combining text and visual input in a prompt for a generative AI model. So let's access the aka.ms/the chat playground that we use in other also sessions. And we are going to really start by asking some questions about some images. So I already downloaded some images that we are going to ask the AI about them. Starting with, why not asking about some cooking. So first thing, we need, before everything, to enable the image analysis. So there is a button to enable it. As I said before, I'm going to use the V3 Mini because it's much faster. So once I select that, this button becomes clickable. So if you do it by your own, so if this button is not working, you need to be careful to enable image analysis. So now I'm going to grab an image, and this is an image of a banana, and I'm going to ask it, why not to suggest me a recipe for this? So what can I cook with this? Which recipe goes with this? So based on the image, it's showing a banana. Here's a simple and delicious recipe for banana pancakes. So it suggested me banana pancakes. Here's the ingredients. And yeah, I can start cooking it right away. This is something I think all of us already, we have done it at least once, trying out to find a recipe with AI. So I can also ask other things. So let me put on here a new chat. So for example, I'm going to grab another image to make sure that everything is fine here. This is a green apple. And now I'm going to ask it, what dessert could I make with this? So it's saying, sharing Granny Smith apple. Here's a recipe for a delicious apple crumble. Give me ingredients, and I can start cooking it right away. Well, looks like a delicious recipe here that we have to maybe cook for dinner. We can also take another picture. Here's an image of a lemon. I'm going to ask it, what should I cook with this? Yes, it's a lemon, definitely. So it's suggesting a lemon chicken. That could be a good idea. I like it. Well, looks like a yummy chicken lemon recipe. I hope that you enjoyed this demo. Well, let's get back to class. In this session, we discussed how AI understands and generates visuals content by covering key computer vision tasks like classification, detection, segmentation, and contextual analysis. The main model types, CNNs, and vision transformers, and how diffusion models create images and videos from text prompts. Remember that all these materials is available for free on the Learning Path, and you can find the full Learning Path at the Microsoft Learn platform. This concludes our session. Thanks for joining us for this session. To continue learning, we encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn. Happy learning!